Now that we've added our users and created our shares, an extremely important function of a lucidlink file space is our data protection capabilities. Accidents happen, whether that be intentional or unintentional. In order to protect your data, it's important to be able to revert to a prior point in time. So if we look back at our command line interface, we have two features within Lucid. One is Snapshot and Snapshot Scheduler. If we look first at the Snapshot Schedule, we can see that we can create scheduled snapshots that happen at particular intervals and retain a certain amount to ensure recovery. Our intervals are in minutes, hours, day, weeks, months, or years. So for example, you could have a snapshot every 15 minutes as a schedule, and you keep 4 for the hour. Then you have 24 hours in a day. So you could have 24 hours of retention on an hourly policy. You can configure this to satisfy your business continuity, disaster recovery, time objectives. You can also complement with a snapshot schedule a standard snapshot. A standard snapshot is manually executed. In our environment right now, where we've got our base directory structure, let's perform a snapshot with lucid snapshot create, and let's specify its name as now. We'll require our root password, and we've now got a snapshot. So if we navigate to our OS client, we'll see our Snapshot tab. Our Snapshot tab across Windows, Mac and Linux mounts your snapshots. If we activate on Windows our Snapshot tab, we will see that a mount point will appear on Windows with our file space snapshots. So we have our snapshot called Now, which contains our directory structure, how it exists right now. Let's, for instance, add some data on macOS and add a text file and put in it macOS. We will save it to our file space within data, and we have our new text file. If we go back to our snapshot, and let's create another snapshot and call it macOS, provide our root password. Let's then go to our Linux machine, go to our data folder, and open our file from macOS, and let's contribute Linux. Save it and close it. Now let's create a new snapshot and call it Linux. Let's now go to our Windows mount point under Data, edit this file, and put inside it Windows. Save it and close it, and perform a final snapshot for Windows. So we're going to note within our snapshots, we're going to have our multiple points in time that we've manually initiated. Our snapshots are read-only and can be mounted across Windows, Mac and Linux and honour our user access control shares. So if we look inside macOS and open up data, we will have a read-only file that reflects macOS. If we change to our Linux snapshot and open up the file, we can see our read-only file contains Linux. If we go to our macOS and activate our snapshots for our user 1, we can see that we'll have a snapshot mount point, that we can select Windows, open up data, and have a look at our snapshot that contains Windows. So snapshots form an important function, whether they be automatic policy-based or manually initiated snapshots, in protecting your data